this in a Google Colab, you could have gone in and you could have uploaded your own cat or dog picture. And it actually does imply that the probability of cat is 1%. So that's the first classifier we started within just 30 or 40 minutes of starting out. Next, we looked at what traditional programming looks like. So if you have your inputs, you pass them through a program and you just get results. That's just traditional programming. How deep learning is different. In deep learning, you have a model that has inputs and it has weights. But in the same way, these weights are assigned to the model. And in the same way, you pass the inputs and you get the results. But the way it's different is that what you want to do is you want to make sure that you're able to update these weights. And we discussed this a little bit, that this is something that's called backpropagation, but we'll learn more about this. But in a way, you have your inputs, your weights go into the model, you get some results. You check how your model's performance is. Is the model performing better or worse? And then you keep updating your weights, because the weights are what are assigned to model. So you keep updating your weights, you keep doing this cycle over and over again till your model has really good weights and the performance is really something that's acceptable in high. So in a way, when you get a trained model, then all you can do is that trained model can have those weights that you learned from here. Those weights can then just be here assigned to this model. And in the same way, it's just like general programming. You pass your inputs and you get your results. So that's just how a trained model looks like. Cool. Then this is where we're going to start today, is we're going to have a look at some of the jargon. So a weights, a model in deep learning world today, a model can also be called an architecture. So the functional form of the model. There's no point in digging very deep into these things, but let's just say you'll hear model architectures together as words that would refer to this thing that's being trained, to this function that's being trained that can actually make predictions. You'll hear weights and parameters almost together. So somebody will call these things as weights, somebody will call them as parameters. You'll hear the word loss a lot. Labels are the actual true labels of the data set, which we'll also have a look into as we go down more into the notebook. And the loss is something that depends on these predictions from the model, and it depends on the labels. So in a way, if you put that jargon into that whole image, you get this. Your inputs, and instead of weights, you call them parameters. They go into the model. Instead of the model, you call it architecture. You get your predictions. You calculate your loss. Loss is just performance. Loss also requires the true labels, and then you just update your weights. So this is just the main idea of deep learning, and this is something. Not even deep learning is something that's very traditional, and these concepts can be applied to all of machine learning today. Cool. So from here on, this is where things are going to be new, and I'm going to slow my pace. And in case you thought I was going too fast, so what are the limitations to machine learning? One of the limitations of machine learning is you can't really do anything without data. Data is key, and a lot of the things and how your model is trained would depend on the kind of data that you have. So the model will only learn the patterns that it will see in the input data. And the model basically creates predictions based on the patterns it has learned from the input data, and it doesn't really do recommended actions. So I'm skipping through the chunks that I believe. I'm going to go through the main ideas of the notebook. So when you go back and you can read through them, and if there's still any questions, you can ask us. But the main things I want to touch upon are how does that piece of code, or what's in those 6 lines of code, and provide you with some transparency. So the first line of code we saw was just from fastai.vision.all import star. That's just importing all your modules and all your libraries and all your function. So untar data is a function in Python, and this is what's importing that function called untar data. One of the things is that's generally frowned upon in Python world, like lots of people who would say, oh, we're professional software developers, or we want to write code in a certain way, in a certain design. They will say importing star is bad practice. But actually, Jeremy says that in a Jupyter notebook where we want to do lots of experiments, it's actually pretty handy to have lots of functions ready, so you can just call them directly. So the next thing that this does is you'll be surprised at how much just this line of code is doing. It's actually url.pets is a URL. So it's something that's the pets URL. That's where the data set is based in the internet. What this untar data function is going to do, it's going to download that from the internet to your local computer. Then it's basically going to unzip it. So you're going to have all the images and all your labels as files. And then in there, there's two folders. One is the images and the second one is annotations. All this does is then it returns a path to the images folder of that data set. Then we defined a function which looked like this. This is just, so sorry, something I should quickly mention is what are labels and what are predictions. I would believe that, so if you have, when you have a data set, so let's say I have 1 million images, then for each image, I have a category. So if this is my first image, then for this category, I could say it's cat, cat, dog, cat, dog, cat. These categories are called labels. And when you make predictions on this data set, basically from your trained model, they're the predictions. So that's the difference in labels and predictions. Predictions are what the model is actually predicting, and labels are the true labels, the true categories of all the images that are there in your data set. So as many images you have, you'll have the same number of labels. So what this is cat function is doing, because we were creating a dogs versus cat classifier. So what you need is in your data set, if you have a data set, again, as I mentioned, you have this data set of say 7,000 images, then what you need for each data set or each image is a label. You need to say that, is this a cat, yes or no? Is this a cat, yes or no? So if it's a no, it's basically a dog. It's just a way of saying yes cat, no cat, yes, no. So that this becomes your labels, right? And this is what the model will use to learn. And one way to just convert, like one way to get these labels is just using this function. So this function is just a way to create labels. Cool. The majority of things happen in this line of code. It's something that starts with something called image data loaders. When you're doing, you'll see in FastAI, it's really convenient, and you will see that when you start with FastAI, if you're working on images, you'll start with the word image data loaders. When you're working with text, it will be called text data loaders. And then a lot of things get passed to this function. You get passed a path, this get image files function as well, and then a valid percentage. So we'll go now and just have a look at what each of these mean. So the first thing we passed is this label func equals cat. That's just, as I've already mentioned, is cat is just a way of telling whether the thing is a cat or a dog. So this label function is just used to label your data set, because otherwise all you have is your data set and you don't have any labels, but you need labels to learn the model, for the model to learn. The next thing you will see is we're passing something called item transforms equals resize 2 to 4. In FastAI, you basically have two types of transforms. You have something called an item transform, and you have something called a batch transform. So what's the difference? Like, what is a batch and what is an item? So let's say I have my data set of 1,000 images. So these are all from 1 to 1,000. So this is my first image. This is my 1,000 image. Then the item transforms are what gets applied to each of these images. So if I apply to each of these images, what these items are, they are actually different from the first items because they have been transformed. And specifically what the resize 2 to 4 is doing, if my input images were of different size, so say they were 256 by 256 pixels, or they were say 512 by 512, then applying a resize transform on each of the items is going to make sure that my transformed data set is of 2 to 4 by 2 to 4 size. So that's the first thing. That's what these item transforms are. And they get applied to pretty much every item in your data set. The next thing then you do is you have these 1,000 transformed items. So I'm just going to call it transformed items here. So you have these 1,000 transformed items. The next thing that you do is you start grouping them in batches of 10. So my first group has 10 images, my second group has 10, and my last group has 10. So if you have 1,000 items and each group has 10, you're going to end up with 100 batches. And I'm just telling you what exactly happens in deep learning. Like, this is the exact process of how you go from having a data set to then training a model. The next thing that happens is then you pass each of these batches one by one to a GPU. And this is where the model will actually start training. A GPU is a graphic processing unit. It's very similar to a CPU, but much faster, much more performant. And this process of once each of the data sets, so you can see how each batch contains different images. Once all of the images or all of the batches have been passed to this GPU once, it's called one epoch. And this process of the model actually learning is called model fitting. I'll take 2 quick questions if anybody has 2 quick questions on what we've learned so far. And we're going to take questions on ondb.me/fastbook2. Okay. So there's no specific questions related to item transforms, or that's fine. I did see a quick question. Can you explain about what an epoch is again? That's okay if you don't understand what epoch is. It is fine, but it's basically just when your model has seen all of your data set once, it's called one epoch. When it has seen all of your data set twice, it's called 2 epochs. So basically, when you do a full pass of your whole data set to your GPU, to your model, that's just called an epoch. Excellent. So then this is just information about the data set in the book. And this is when you'll read, you'll see this, that it's the pets data set. It has 7,400 pictures. And the picture names are something like this: Great Pyrenees 173.jpg, which just means that it's the 173rd image of the Great Pyrenees breed dog in the data set. This is important. So this is data set information that we use to label our data set. The file names start with an uppercase letter if the image is cat, and a lowercase if the image is dog. So if the image name starts with a capital letter, it's a cat. And if it starts with a lower letter, it's a dog. So that's why, if you can see, we had something like this. Is upper basically is just a Python function that says, is the first letter capital or is the first letter small? So in that way, you can actually classify just based on the image, just based on the file names, you can classify them as cats and dogs. This brings us then to the most important part of this whole exercise, which one of the key parameters that we passed was this one here: valid percentage equals 0.2. So what is this valid percentage equals 0.2? This is something that's really, really important, and I do have a small image to explain this. I told you that when you have your items, so this is my first item, and let's say this is my 1,000th item, then what you do is, if your valid percentage is 0.2, that just means you split your data set, 80% of it becomes your training set, and 20% of it becomes your validation set. What's the difference in the training and the validation set? This is something that's really, really important. The model the model learns from the training set, and the model is tested on the validation set. What this means is the training set is what the model is actually seeing. When I say what does it mean that the model is actually seeing, it just means that there's going to be 800 images. If the cats and dogs had 1,000 images, then these 800 images are what the model sees. And these 800 images are what the model learns from. But then you have your 200 images of cats and dogs again. So then what you do is you make the model learn from the training set. And then you take these 200 images and you predict you make the model say, okay, here are 200 new images that you haven't seen so far. Can you make predictions? Can you say if all of these 200 images are cats or dogs? So from 200 images, it will say, okay, 150 of these are cats and these 50 are dogs. But then based on those predictions, you can actually check how accurate your model is. You can actually check the performance of the model. So we always want to check the performance of the model on a validation set. It's also called a holdout set because you pretty much held out 20% of the data set straight away. So that's the key difference. And I'm just going to quickly touch upon something which is called overfitting. So you might ask, okay, why do we need a validation set? Like, what's the purpose of it? So the basic and the most easy example is this one. So let's say you have a list of points on your 2D graph, right? If you don't have a validation set, or basically fitting is a way of checking, like, if the model just picks the patterns of each of these points like this. Because imagine in real world, what you're going to do is you have a trained model. So your model is going to be trained, and then you're going to take it up in a real world. You're going to take it up and you're going to ask it to make predictions on other data, right? That's how things are going to be in the real world. So say if you're a medical company, what you're going to do is you're going to give the model, say, 1 million X-ray images. And then in the real world, when this X-ray model that can tell if there's something in an X-ray or not, when it gets applied or it gets used in a hospital, then the X-ray images that it's going to see are going to be completely new. So what we want is that we want the model to learn the patterns. We want the model to learn these patterns, and we want the model to learn the general patterns from this training set. But we don't want it to memorize the training set. By memorize the training set is, I just mean that if you give the model the same images 10,000 times, then it's not going to be able to do a good job on making a prediction on a different image. So that's the difference. We need the model to generalize. And when a model that looks like this, when it has pretty much memorized your data set. So this is called memorizing the data set. I'm just going to say memory. But this is where the model has memorized the data set. And this is what a proper fit looks like, because it's just learned the general patterns. So that's just a difference of using a proper fit and a overfitting. Finally, what we did, and we will have questions after, I'll give some time for quick questions after this. Finally, what we did, this is the 5th line of the code that we saw in those 6 lines. We created something called a CNN learner. So what's a CNN learner? A CNN learner is a convolutional neural network. In this book, it says the convolutional neural networks are state of art today, but this book was written in 2020. What's happening in 2021 is that there's new architectures, there's new models that are catching up to convolutional neural networks. But for your understanding, convolutional neural network is just a way, it's just so you know how we had a model that we defined like a black box? A CNN or a convolutional neural network is just a type of model that can actually learn things from your data set. So it can be used, it's widely used in images. It's widely used. It's also sometimes used in text, but widely and everywhere in image classification or image related tasks, you will see a CNN being applied. So the next thing we did was we picked something called a ResNet 34. It's just a particular type of a convolutional neural network. So what ResNet is just a type of a model architecture. And the number 34 in ResNet 34 tells you that that's how many layers there are in this model architecture. It's completely okay if you don't know what ResNet is, if you don't understand what convolutional neural network is. As we go into the next chapters week by week, everything will make sense. And in fact, by I think it's the 18th or the 19th week, we will create the ResNet architecture from scratch. So basically, we will know exactly then the nuts and bolts of what ResNet is. But because you're seeing this the first time, you're hearing the word ResNet the first time, it's just an architecture that works for image classification. It's just a mathematical function that can predict or classify cats from dogs very easily. So the number 34 is just the number of layers or how big this network is. It basically means that ResNet 18 is smaller than ResNet 34, and then ResNet 152 is one of the biggest networks. So the last thing then, what is a metric? So the metric is just a way of checking how good my model is doing, how the performance is. But something I really want to highlight here is a difference in a loss and a metric. So the difference in a loss and a metric is this. A loss is what your model uses to train, basically. So because we know we were doing backpropagation or we were doing SGD, so loss is something that this stochastic gradient descent or just this process, I'll go back to this image at the top. Okay. So you have your model architecture, which has some parameters. This is how it looks like. You get some inputs. This architecture makes some predictions. Then you calculate the loss based on these predictions. So I think by now you should already know what predictions and labels are. So based on these predictions and labels, it calculates the loss and it updates the parameters again. What this loss does, this loss is easy for, so SGD is what does the actual update. I'm just going to call it stochastic gradient descent. SGD is what is used to update the parameters. And loss is something that's really helpful for the SGD to know how I need to update the parameters. But then what's a metric? So what's a metric? So when you have a trained model or while you're training your model, when it looks like this, you have your inputs, you have your model, and you have your result. Then on the data set, let's just call this data set, you have your 1,000 images and you have your 1,000 labels. Then it's going to have 1,000 predictions. So between the labels and the predictions, you can actually check the accuracy of how accurate my model is. And that accuracy is a metric. It's not being used by the model to actually do the learning, but it's good for us as humans when we're training these deep learning models. It's good for us to know, okay, I know that my model by the 5th epoch has 50% accuracy in classifying cats versus dogs. And I know that the model by the 10th epoch has 100% accuracy or something like 95% accuracy. But that's just a number that's good for us for reporting purposes. It's not helping the model train at all. What's actually helping the model train is the loss function that tells the model how to update the weights. And that loss function is in general, in a image classification is a cross entropy loss. So that's a key difference. It's okay if you don't get the most of it, but as long as you get a general idea of the difference between a loss and a metric, that's good for me. And this is the last thing that I'll touch upon before we open the thing for, before I open it, before I let you guys ask questions that you might have so far. But something that you do you would have, if you've read the book so far, something that you would have seen is, or heard in the wild, is something called a pre-trained model. So what is a pre-trained model? If I'm going with a ResNet 34, it would have 34 layers. Then I basically have one massive data set. Let's just call it 1 million images. This massive data set is called ImageNet. So what the model does is it actually first learns from this ImageNet data set. And we'll see how this is important and why this is important. But the model basically learns from these 1 million images first. So this is what a trained model looks like. It has some weights, and it's learned on these 1 million images called ImageNet. Then something that we do is we remove the final layer. So this thing is gone. And we replace it with something called a head. So it's just a new head. Because when you're working on your cats versus dogs, ImageNet has 1,000 categories. By 1,000 categories, I mean some images are that of a fish, some images are that of a human, some images like could be a dog, could be a piano, could be like all of these different 1,000 categories. But because what we want to do now is, instead of predicting on the 1,000 categories, we just want to predict on 2 categories. We just update this final layer to do this. But we keep the same weights from the ImageNet to here. So this part of the architecture is actually the same as before. And this process of first training a model on a general, really large data set like ImageNet, and then fine tuning it, or then basically training it on your small data set that you care about, is called fine tuning. And it's specifically called as using the pre-trained weights. So these it's basically before you do the actual training of the cats versus dogs, you're doing a pre-training. So just before you're doing a pre-training on ImageNet. And this is called as using the pre-trained weights. When you use the same weights for the new model, it's just called using as a pre-trained weights. So that's what you will see is called a pre-trained model. And then what is this process called fine tuning? Just this process of like not actually training any of this. Like we're not actually updating this part of the model. We're just using the same weights, but we actually train just this new part of the model. This is what is called as fine tuning. When you keep the stem, or you keep the bulk of the model as the same. All right, that's it. That's the whole piece of code, and that's exactly what that's exactly how those 6 lines of code work, and that's all the deep learning jargon that you need to know right now. So let's spend 5 minutes on questions that are related specifically to these things, and I'll spend 5 minutes trying to answer them. Okay, thanks. That's a really good question. So the question is, it seems like fine tuning trains the whole part of the network, but I've also heard as this words of freezing layers or these things. What's the difference? So what fine tuning in Fast AI does is it does 2 passes, 1 and 2. In the first pass, it takes this model where just the head is new. So just this head is new. It takes this model as is, and it trains just the head. Trains, it does not train. So this is the head, this is the stem. It does not train the stem, it trains the head. So this is the first pass when you call fine tuning. This is just the first pass of what happens in Fast AI. And this process of not training the earlier layers of your model is called as freezing the earlier layers. But you're actually training the head. Okay, so that's the first pass. In the second pass, then what happens is now you have, I'm going to call it a trained head. So I'm just going to call, because the stem is as it is, but your head is trained. The next thing that you do is you actually train both of them. So I'm just going to call it train yes, and train yes to both of them. But you train this side of the head a little bit faster than the stem, and we'll see why that is. But this is how fine tuning works in FastAI. So that's the question. So I hope that answers. It seems like in fine tuning used for cats versus in chapter 1 retrains all the layers. Yes, it's the second part of fine tuning that does this. But I've also heard the idea of freezing some layers. So now you know what freezing is. And I wasn't able to find parameters that does so. It's just fine tune. So what does the one signifies in learn.fine tune? It just means that you have one epoch. So you do this once, and you also do this once, but it's actually like two separate things that you do once. But if your epoch number was say 5, then you repeat this step 5 times. Repeat this step, but not like this one is only in the first one, so this doesn't get carried on to the next ones, but you're training your model 5 times. And the reason why you need to have like higher number of epochs is because the model in just one epoch can't really understand what exactly your patterns in your data set are. That's been answered. This has been answered. All right. So that's the basics that we need to know about in fine tuning, and that's the basics that we need to know about what pre-training is and how this works. So the next thing that we need to touch upon is this idea of what the model actually learns. So I told you that a model looks like this. Like this is the final layer. It's called the head. ResNet 34 has something like 34 layers, which you can say break into groups, or let's just say, I mean, it's still 34 layers, but for simplicity, let me say I'm having a very small model. Instead of 34 layers, I just have like 6 layers. Let's say I have 6 layers. So this is first, 2, 3, 4, 5, and then 6. What's really interesting is that a deep learning model, each layer learns different things about your data set. So the first layer, this is my first layer. The first layer is actually just learning how to tell edges. It's actually just learning like, okay, this is how a diagonal looks like. This is how a diagonal looks like. It's just learning how to tell edges. It's just learning how to tell diagonals. That's just the first layer. But the second layer builds on top, and it starts to learn patterns like circles. It starts to learn patterns like these kind of like top left edges, because it's now building on top of what the first layer learns. So the first layer already knows about these edges. It already knows about these things. And the second layer builds on top. And based on that, based on these patterns, it can actually learn things like, so for example, based on this pattern, you can see how it's able to tell sort of like windows. So by the second layer, the model is able to tell like all these small different objects of like patterns. It's able to tell this pattern. So it's learning some patterns that are built on top of what it learned in the first layer. Then it combines these patterns in the third layer, and you can see how by this time, it's not only able to tell circles, but it's also able to tell circles and like edges together. So it's combined them. It's able to tell more complex patterns like over here. It's starting to tell human faces. It's starting to learn things about like bees. It's starting to learn things about what fur are in my cats and dogs. So it's basically slowly and steadily the model by the third layer is learning more than what it has in the first and the second layer. By the fourth layer, again, it's learning more complex patterns and like proper images of dogs, proper images of of basically birds or animals. It's learning proper images of. So not only now does it know spheres and edges, it now can tell cameras. And by the last layer, it can actually do the task that you want it to do. So this was the Zeiler and Fergus paper that kind of visualized how these different parts of the model learn. And something I want to stress upon is, when I said pre-trained weights, what we actually do is we remove the last layer, right? So the last layer, if it was trained on ImageNet or like 1 million images, this last layer is what is learning all the patterns, right? But what I want to do is now, instead of doing this, I want to learn cats and dogs. But for learning cats and dogs, things like learning about what fur are, or things like learning what edges are still going to be important, right? So these weights or these things that the model has learned in the earlier layers is still important. So this is still important. And you're not starting from scratch when you're training on your cats and dogs. By now, your model already knows things like, okay, what are edges, what are spheres, what are common patterns. And that really improves the training, and it really helps the model have significant performance. Like without pre-training, this process is called reusing weights, and it's called pre-training. Without pre-training, it's really, really difficult for the models to converge, and it takes much longer. It takes lots of more compute. So this is really the key idea in computer vision, is that if you can reuse the weights, this is gonna help. And then you can see how it's like, you don't really, the last thing I'll touch upon in this chapter is that you don't really need to train like the first part, which can just learn these edges. You don't really need to retrain the model, right? So if you can keep these weights as is, but make the model learn the later edges of the part faster, then that's just going to help your model in general, because we don't really want the model to now reset if the learning rate in the early bits of the model is really high. I mentioned learning rate. I shouldn't have said learning rate, but you'll see what learning rate is in the coming weeks. So then this is the last part of the whole chapter, is that you can't really, it's not just like deep learning is not just for image classification, but you can do things like spectrogram classification, time series. This was one where it was used for fraud detection. So you can actually convert all these different domains to images, and then you can train an image classifier on top that can actually do the classification. So I guess the idea is that image recognizers can handle non-image tasks. Because if you can convert like music spectrograms, so if you have a spectrogram and you can plot it on an image, and then you train an image classifier on top, then you're actually able to tell spectrograms, so you're able to separate these audios. Like you can tell how gunshot is different from engine or basically from street music. But in essence, you don't have to learn anything new if you know how to do image classification. So this is something I really want you to think about. If you're in a domain, if you're in an industry where you can convert your data set to images, then trust me, training an image classifier on top will really give you good results. So have a try at, like if you're in a time series, then try plotting that time series as this person did, and it's something called a Gramian angular difference field. I have no idea what that is because I'm not from the domain, but apparently you can plot time series as images. And then if you train your models on these different images, then it's really helpful and can actually tell different time series patterns. And then the last part of this whole chapter, so the question then also is, how is deep learning different from machine learning? Every concept that we've learned so far is applicable to machine learning as well. But what makes deep learning distinctive is that it's just a particular type of architectures. So these ResNets, these ResNet 34, ResNet 50, these are just particular architectures that that are common to deep learning and are different from machine learning. But in machine learning, you have things like XGBoost, random forest, and others. Finally, I'm going to skip through this part quickly because it's very much okay if you just go back and read through it. But this is just an introduction that deep learning is not just for image classification, because so far we've only seen examples of image classification. But you can do things like in an image, you can actually tell, like, okay, these are the exact pixels of the road. These are the exact pixels of a footpath. These are the exact pixels on the left of buildings. These are the exact pixels of sky, and so on. So you can actually tell pixel by pixel in an image, which is really helpful in autonomous vehicles. So that's called the image segmentation. You can also tell sentiment reviews or movie reviews, which is the most common example. So if you say, if you give the deep learning model something like, I really like that movie, it can tell you if the review is positive or not. And then in Python, basically when you're using FastAI, if there's any function that you have a question about, something that you can actually do is you just write the word doc before that actual function, and it will open up something like this, which will actually tell you what it does. You can click on Show in Docs, which will take you to the FastAI documentation. So let me see if I can bring this up quickly on Jupyter. So see how that brings the documentation up for UNTAR data. And I can now click on Show in Docs. That will take me to the FastAI documentation. It has plenty of examples on what it does. And I can click on the source here, which will take me to the source code of basically any FastAI function. So you can use this for any FastAI function. I just wanted to quickly highlight that. The last thing you would be surprised to know if you're new to deep learning is that it's also possible to build models on tabular data. So if you're from a finance background, if you're from a medical background, and you have like all these tabular, and you want to tell basically, as an example, this example uses adults data set, which tells if an adult is in a higher earning if he's earning high or less based on all these other factors like age, occupation, and that's just a tabular standard data, and you can actually now train models on tabular data as well. That's the most of it. I did want to touch base on validation and test sets as well. So far I've told you that validation and test set is when you have your whole data set, then you just keep 20% of your data as separate. You train the model here and you validate the model here. But the thing is, like, how do you split? Like, how do you find this 20% data set? So if you have, this is where this is a key example to think about and to know, and this is again something that's applicable to machine learning as well. If you have a graph that looks like this, where you have date and sales, then something that's really common practice is called like a random split. So what you do is you just take 20% of the data from anywhere, and you put it in the validation set, and it's called like a randomly picking up this data. But that's actually going to give you wrong results, because when you're trying to predict sales, like it's going to give you, when you look at the accuracy, or when you look at the metrics or the performance of the model, you're going to have the wrong performance expectation. Because when you take this model and you put it in a real world, then what you're going to do, in a real world, you're going to try and predict sales for a future date, right? When you have a trained model, you're going to put it in production. Say you put it on production on the 1st of January, then what you really want to do is you want to make the prediction be done for the 2nd of January, for the 3rd of January. So what's really helpful, a better way of creating a validation set is that you keep divided by timeline. So this is a much more real case scenario of having a proper validation set of 20%. Because if the model can actually perform good here, then you have a much more confidence that this model can actually work really well in a real world use case. Lastly, this is the end of the chapter. This is where you choose your own adventure. So this is where find projects that are of interest to you, whether it is Tableau, whether it is computer vision, whether it is NLP, but find things that are of interest to you and pick your own adventure, because we want to be able to, you want to be able to go back and you want to be able to run each of these lines of code, and you want to be able to basically understand from a high level here on what's happening. And Sayam has already shared the share your V2 projects on forums.fastai. So if you go, oh, sorry, is that what I started that back in March 20. Anyway, the idea is then on these forums, you'll see a lot of people will be sharing all in all of their ideas, their own projects. So Radek has his own ideas, and he's working on audio classification. So if you are out of inspiration, then definitely go to this page or this forum post here and pick your own basically project that you want to work on. And lastly, every chapter comes with a questionnaire. It's really, really important that you then, everything that you've learned, you stop at the questionnaire, and you go to the questionnaire and you go to these 33 questions. And you need to be at a point where you're able to answer at least 25 of 33. But if you have to like reference back, that's okay. But it's just for your understanding that you're able to answer all these questions. So for example, what does weight assignment mean? I just picked this up randomly. But this basically means that a model has weights, right? A model has weights associated with it. So this idea of a model having weights is called as weight assignment. So I need you to go back. I need you to reread this chapter. I need you to run the code again and then see if all of these questions make sense. And with that being said, we are ready for chapter 2, because we also want to give time to Tanishq to present some of his work and his journey. So I will take 5 minutes of questions again. Oh, hey, Parul, I didn't realize you're attending. There's a blog series on Fastbook. Oh, yes. I did say I would mention this. So this is, again, a wonderful resource. Thanks for sharing, Paro. This blog series would have basically each chapter as a blog in a simpler language. If you want to refer to this, it's by Ved Gilliam. He's also a FastAI person. So you can go back and you can have a look at these blogs. Okay. Since the categories from pre-trained models are reduced to 2, does that imply? No, that's an incorrect understanding. So I would recommend that you go back and have a look at. Sayam's already answered most of them. Oh, thanks, Sayam. Is there any questions, Sayam? I'm going to make you 1 second. Let me make you panelist so then you can talk. Hey, Sayam, is there any questions that you feel we should look at? You should be able to talk now.
Sorry, I got promoted and I rejoined. No, I don't think any question is unanswered.
Okay, excellent. Then thanks for answering all the questions. Really appreciate your help.
Sure thing.
All right. Say, I'm sorry I took you by surprise and just made you a panelist right there. But now, as it's we're towards the later end of the chapter, we're going to Uh, we're going to spend now just 15 minutes on chapter 2 production, which is going to help us understand what's coming next. And then we will have Tanish present on his journey of how he started with Fast AI and how he's come to where he has today. And then we'll also have an informal catch up on Slack just to meet each other. All right. With that being said, let's get started with chapter 2. So chapter 2 is really interesting. Like chapter 1 gives you a highlight of everything that's going on in deep learning world. Like it gives you an example of how you can use fast AI in just 6 lines of code to train text classification models. How you can use fast AI to train image classification models. But actually, deep learning and having worked in previous industries as well. Uh, it's more than model training. When you actually want to create a company out of an idea, or you want to put things in production, production basically means when your customers can start using your product, or not just customers, but basically users. So it's in a final stage where people can start using your product. When you go from when you go from like having an idea to then going from this stage to actually being able to serve your model so people can use it, it's actually more than just model training, because you need things like you need data, you need infrastructure, you need to have like really good basically coding practices, you need to have tests. There's just a lot more that does happen than just model training. And so far in chapter 1 we've just seen model training. So then the next thing is the practice of deep learning. So in this chapter, we're going to have practice on an end-to-end deep learning problem. Like, how do we get the data set? How do we train the model? How do we serve it in production? How do we create a user interface on the internet so then people can come and they can upload their own images and try? And uh, we've seen in first chapter is like 6 lines of code are something that can be used for text, images, basically tabular. But deep learning isn't magic. So those 6 lines of code won't work for every problem. But the mindset that you want to have is you want to have an open mind. Like you want to have an open mind and you want to think, okay, maybe deep learning can solve this. And maybe I should try solving a problem using this particular idea. And maybe I can convert my tabular data to images. Maybe I can convert my spectrograms to images. And that's the mindset that you want to have. You want to have a really open mind. And if it doesn't work, it doesn't work. Well, it's an experiment that you tried and you failed, but you learned out of it. So starting your project, as I've said, when you're in production, that's just me drawing an image of you. So I'm really sorry if you don't look like this, but you don't want to be spending, like if you have 3 months to work on a project, you don't want to be spending 2.5 months training a model. You actually want to be able to spend equal time in, like on each of these different parts of deep learning, like getting the data set, labeling a data set, then modeling, and then serving it in production. You really want to be able to spend equal time, because then that will give you the skills and that will give you a really good exposure to all these other things. So the goal is not to find the perfect data set or project, but just to get started and iterate from there. So in your first iteration, you have something that's working. So that's your first iteration. It's okay if your model is really small, if the performance is 70%, or I don't know, if the performance is not up to the mark, if your data set has errors, if the labels are bad, that's okay. Like if there's some wrong labels in your data set, that's completely fine. What you want to do is you want to go in iteration. So in your first iteration, you want to do this. In your second iteration, you want to improve things. Then in your third iteration, you want to still improve things. And by the time you're in your fourth iteration, you would have a pipeline that's working really beautifully. And a lot of Kaggle grandmasters, a lot of people on Kaggle, and Singam would definitely know more about this because he's interviewed, I don't know, 50 or hundreds of them, and he works at H2O AI. But a lot of Kaggle people have all these ways of like starting with a MVP version, and then you just iterate and iterate and iterate till you have something that's working. So you complete lots of small experiments. And where do you start doing these experiments? Because from this week, you want to go back and you want to start training you want to start training the model on your own data sets. Well, you start with the project that's related to you. You start with the project that's related to where you work, so you have access to data. So if you're a medical person, you start with X-rays and CT scans. If you're in a biology kind of a field, you work with proteins, then you work with protein sequencing. If you're a wildlife photographer, then you have like hundreds and thousands of wildlife images. That's where you start. If you're a music person, you start with audio. If you're working with lots of tabular side of things, I wouldn't, on a side note, like, I wouldn't 100% recommend on starting with tabular, because tabular is still keeping up with text and images. So if you get stuck in a problem, you won't have 5 other people trying to answer it for you. So it would be easier if you start with images and text, but you're more than welcome to start with Tableau. Like Tableau is now becoming a mature field anyway. But I would just say take your pick and start with somewhere where you belong. So it should be related to your field of interest. And the reason why it should be related to your field of interest is because if you're just doing it for the sake of it, you won't finish. So as I said, CV, text, and tabular is where you can start pretty much. So the state of deep learning, because this book was written in early 2020, I'm going to actually skip this for now. And I just want to spend 5 minutes on this section of the notebook first, which is gathering data. So we will go back to look at what deep learning can do today. But something I want to spend time on is, as part of this chapter, what you're actually going to be doing is you're going to be building a grizzly bear, or basically a bear detector that can classify 3 types of bears: grizzly, black, and teddy bears. And the first step, as I said, is getting the data set. So there's like all these different projects that you can do. And one of the really funny ones that Jeremy once mentioned in the Fast AI course is that somebody built a deep learning model for his fiance, basically, so she could classify the 16 cousins during a Christmas vacation. So she could get the camera out, take a picture, and then the model will tell you who that cousin is, because she can remember the names, which is really, really interesting. And it's we've seen applications of basically people trying to categorize their WhatsApp images into all these different categories. So take your pick that you feel you can do. And I just want to show you how you can get your data set, because this is something that's really going to help you, and it's really going to be important this week, is that you want to, this Fast AI basically uses something, a Bing image search. So if I go and I type Bing image search, and I type, say, I want to do grizzly bear detector. So I type grizzly bears. Then these are the a lot of images that I get for grizzly bears. And if I want to make a grizzly bear versus teddy bear detector, then I can just search teddy bear, and that will give me all of these teddy bears. So something that you will have to do is you will have to go to Microsoft Azure and you'll have to sign up. What that will do is that will give you an Azure search key. It's okay if you get stuck on forums.fast.ai. If you go, there's plenty of resources. Actually, should be here. So if I search Azure key, then you will see like there's all these different then you'll see all these different posts on how you can get the image search key, basically. So something you want to do then is you want to go to Microsoft Azure and you want to sign up. Then you get the key, you put your key in like this. Then there's this function called search images Bing. So you're more than welcome to call like doc search images Bing, which will bring up the documentation and the source code. And then when you say search images Bing, passing in your API key, and you just say grizzly bear, then what this function is going to do, if I said teddy bear, then all of these images are going to be downloaded using an API. So then you get your images, and you pretty much have 150 images now of grizzly bear. So these images are just paths or URLs that look like this. I can download them using the download URL. I can provide a destination that this is where I want to basically download this image from the internet to this point. And then if I open the image, here you go. This is an image that's been downloaded from the internet. So what this line of code does is that for each of these grizzly, bear, and teddy, it searches grizzly bear, black bear, and teddy bear. And for each of these bear types, it will download the images. So by the time when you get all your images, basically get the paths of all the images that you've downloaded so far, this will return all those image paths. You can see how there's 406 images. So we, just by doing like these 10 or 15 lines of code, we have 406 images of grizzly bears. And then something that you want to do is you just remove the corrupt images. So by corrupt images, I mean, these could be black images, or these could just be having some corruption or some noise in them that you really don't want. Or in a teddy bear, it could be a picture of a football. And then you just remove them, and you finally have your data set ready. So that's the first step of your model training. Like, you're now ready after this point, after running these 10, 15 lines of code, is you're ready with your data set. So by now, if you're someone who loves cricket, which I do as well, you can actually take the cricket players take the pictures of all the cricket players in a team that you support. If you're a football person or a footy person, then you could actually even use sport, and you could try and classify them. So I want you to go back, and I want you to this week run these lines of code and make sure that your data set is ready. And if you're feeling enthusiastic, then keep going forward. And by the time you finish, you would have trained, you keep going forward, and you keep following these lines of code until you get to this point here. So then by now, you would have built an image classifier that can actually tell, that has really low accuracy, and you can form a confusion matrix. We will touch upon what each of these things do, but it's actually the same code that we saw in the first chapter. You create your convolutional neural net, and then you say fine tune 4. 4 just means you run 4 epochs of training. So yeah, so this is the homework for this week. We're gonna stop here. Next week, when we come back, we're going to look at where deep learning is in all these other fields, what it can really do. But for this week, go back, read the first chapter, run each and every line of code that was there in the first chapter, and then you run. You look at the questionnaire and you answer the questionnaire, and then you come to the second chapter and you make sure that your data set is ready. Like, this is the bare minimum that you have to do this week if you want to follow along next week. So thanks for that. I'll stop sharing my screen now. We are left with 15 minutes, and that's Tanish. Hey, Tanish, you still here?
Yep, I'm still here. Yeah, let me share my screen. Okay. Can everyone see my screen?
Yes.
Okay. Yeah, so I guess I'll get started. Yeah, but before I get started, I just wanted to also mention, I know that Amin was talking about the questionnaires. I think I had posted some of the the solutions for some of the questionnaires, especially for the first 12 or so chapters. So after you've completed it, if you want to hear another perspective, read another perspective, you can check that out. And it's also a wiki, so some of the other people on the forums have contributed to those questionnaires, and so you can check that out as well after you've completed them yourself.
Hey,
yeah.
Sorry, do you have a link for people to follow, or these are the Fast AI forums, right? Do you have a
Yeah, I think if
link?
you
Or
just
you can
search
share
up
them
Fast
after?
AI, yeah, I can share them afterwards, but if you just search up Fast AI questionnaire, they should come up. But yeah, I can share them afterwards in the Slack or somewhere. Yeah, so I'll just get started with my presentation, and I'm just talking about my machine learning and fast AI journey and providing a little bit of my advice as well. I know some of this is quite similar to what Jeremy has been mentioning as well, but I think it's also just helpful to see some examples of this in practice as well. So yeah, just to get started, talk about here, talk about my machine learning journey. I started becoming interested in machine learning back in 2015, 2016, and I actually started out by taking the Coursera course on machine learning, which is also a quite well-known course. And it talks about some of the basic concepts of machine learning. But even at that point, it was fairly outdated as a course. And while it provided a basic understanding, there were some other concepts that it did not provide a thorough explanation of. And then also, I heard about this platform known as Kaggle, and I had actually joined the platform back in 2016, a long time ago. And just actually want to briefly talk about Kaggle because I think it's an important platform for anyone who is interested in machine learning and data science. Kaggle is a platform where it's basically, the platform to be where if you're interested in learning machine learning and data science, and they have various different resources, and also more importantly, they have these competitions that they host, and these are competitions where they have actual real world tasks, and people from around the world are competing to develop the best models for these tasks. So these are some of the active competitions that are going on right now. There's one for COVID-19 detection. There's one for alien signal detection. There's some text classification problems as well. So where's different tasks are available. And of course, all the previous competitions are available as well. So here's some examples of previous competitions, and you can also look for competitions based on the type of data. And so this is just generally a great resource. And also if people upload their own data sets where you can check out other data sets as well. And people also share code for these competitions and data sets. So for example, some data analysis, some starter notebooks and pre-processing code, all kinds of code is available to help you get up and running with some of these competitions. And also discussion forums where they talk about the competitions, different ideas, resources, etc. And there are also some short courses that they have on various topics as well, which can be useful for supplementing your journey. But to go back to my journey on Kaggle, I started out on Kaggle, just trying out some of these competitions, looking at the notebooks and the resources provided, and trying to start out with his notebooks, make some changes, submit, and work my way up. But unfortunately, it didn't start out very successful. Some of these competitions I did not perform as well, and I guess after a certain point, I kind of gave up on Kaggle, and this was back maybe 4 or 5 years ago. But then after a while, I actually revisited Kaggle and was looking at some of the competitions, and I kind of discovered the FastAI library. And I noticed some of these notebooks were using the FastAI library and performing quite well. I think some of the notebooks by this person here, I Foss, I don't know how to say his username, but some of his notebooks used FastAI, and they were quite helpful. And it seemed like FastAI was really helpful for people to get up and running and perform well in these competitions. And that got me really excited, especially when I saw there was a whole course behind this library. And so I wanted to explore this course and get started. So, I was able to take the course back in beginning of 2019. At that time, they had released a new iteration. So I started diving into that new iteration of the course. And I just want to talk a little bit about what I did when working through the course. And I want to bring up Jeremy's slide that he had mentioned earlier about how to do a FastAI lesson. He talked about watching the lecture, experimenting with the notebooks, reproducing the notebooks, and also more importantly, repeating these experiments with different data sets. And this is what I really focused on with my FastAI journey. And again, I was looking at resources like Kaggle to help me be able to do this. So here are some examples of some of the notebooks that I had written up when I was taking the FastAI course and exploring some of these topics. So my background is in biomedical engineering, and I'm interested in medicine and biology and healthcare. So you can see some of these notebooks are, are focused on tasks like blood cell classification, diabetic retinopathy diagnosis, ultrasound nerve segmentation. So I was looking at, how to apply deep learning to some of these tasks, these image classification tasks or segmentation tasks. And I was also interested in a couple of the ongoing competitions. So there was one competition looking at earthquake prediction, and I tried out the FastAI tabular model when I was learning about that. And apparently, I didn't submit this to the final competition, but apparently this would have gotten me within the top 5% of the competition, or you would get a silver medal for that competition. So I still regret that I didn't submit this yet. Didn't submit this to the competition, but I'm quite impressed that, even with the basic concepts that we learn, this can take us quite far for real world tasks. And then another aspect is, can you do after you train a model? You want to share your knowledge with the world, and also to solidify that knowledge yourself. Being able to communicate your work and prepare a project that others can see is an important aspect. So this was actually some advice that was provided by a Kaggle Grandmaster, but I think it applies to any sort of machine learning project, not just Kaggle projects, but any sort of machine learning project. I think this is a great way of sharing your work. You can put it on a GitHub repository, prepare a Colab demo, prepare a web application demo, writing a blog post. These are all great ways of sharing your work. And I just wanted to provide some examples of that. So, I definitely was very interested in this diabetic retinopathy diagnosis problem. So I actually, prepared a GitHub repository. I have some experiments here in my notebooks folder, and there's some details in the README about the different experiments. And I have the models also uploaded, and I had made a web app, and that web app is available it's a Heroku app, and it's still available. You can check it out. And you can see here, it's just a simple application. I was able to find a template, and I just play around with the template. But it's just a great way of just sharing whatever you have out with the world, and having people check it out. So, and I think it's just a really great educational experience.
Sorry, just to add, sorry to interrupt, but just to quickly add is, as part of chapter 2, we'll actually be building web apps. So by the time you come back next week or throughout the week, if you want to read chapter 2, you will be able to build a web app exactly like this that solves the problem you're interested in.
Yeah, that's a great point. Yeah. And then another project of mine, a more recent project of mine, has been focused on this particular type of task known as unpaired image-to-image translation. And what I've been doing is I've been implementing this in FastAI and preparing it as a library for others to use, and also training models, sharing those models. And this is and also one thing I'd like to point out, and maybe we could discuss this later, but it makes it the FastAI also has a separate tool for developing libraries, and in fact the FastAI library is based on this tool known as MBDev, and it makes it really easy to do things like this. And I think that's another great tool if you're interested in this sort of thing of maybe developing model implementations and sharing it with others, or whatever sort of machine learning project. Maybe this is a good approach to for doing so. It makes it much easier, where you can just have a series of notebooks with documentation as part of those notebooks, and you get a nice documentation website. Of course, you have your library, all part of this, all due to this MBDev package. And of course, I have a simple web demo also. I know that the FastAI book has its own, it talks about, I think, Voila, I think is the web app tool it uses. But, I would, if you're interested, I would also investigate this tool known as Gradio, because this tool actually makes it really simple to create web apps. It only takes a couple lines of code to actually take an existing inference model prediction function and make a web app from that. So if that's might be something you might be interested in checking out as well. Okay, so I talked about how we can take a project and present it for the world to see, and how you can share your work. I also just want to go back to original story of how I started out with FastAI, finding it on Kaggle and learning about it, and after I took the FastAI course, how it's tremendously helped my experience on Kaggle, and I've also learned a lot from Kaggle as well, and I've been able to participate in some of these competitions and obtain positions in some of the top 5% or top 3% of the leaderboard. So it's been a quite interesting and educational experience. And another aspect is I've been able to share some of these tutorials, starter notebooks, and data analysis on the Kaggle as a Kaggle notebook, and I've been able to reach a Kaggle notebook master title. And also similarly, I've been also able to reach discussion master title, sharing different resources, asking questions, etc. And there are also other FastAI Kagglers. I just wanted to highlight a few others who who have done a lot with using FastAI. So of course, Radek, I know we've heard a lot about him, and he's also experienced Kaggle master, and then Foss is also another Kaggle master. Both of them share amazing notebooks and starter material using FastAI. This is another Kaggle master who has performed well with the FastAI library. Also another Kaggle master who has actually won a competition with FastAI. So all quite impressive feats by other FastAI alumni.
Yeah,
and then
Dr. Habib is really he helped me with blog posts as well. So Dr. Habib, I know all of them are really open to answering questions, and Dr. Habib has then also contributed to blogs, and he's also helped with the Vision Transformer blogs that we've written. So I just wanted to really point that out as well, that on top of Kaggle, it's these guys really are who we look up to when we first started, and it's just a very sharing, and it's a very giving nature that they have.
Yeah. And then of course I think we've already discussed this a couple times today, but also it's important to share your work with the community, and people will people will love to hear what you've been working on, and of course this is the post that you should be sharing it on the FastAI forums. So I often share whatever Kaggle notebooks or projects or whatever, I share it on this, and others have been doing so as well. And of course it's important to contribute back to the community. I know that Amin has been doing this whole Fastbook reading session as a way to contribute to the community. I've been contributing by asking and answering questions on the forums. Both are equally as important, both asking and answering, and that has made me a top contributor on the FastAI forums. And then also I've been adding features or fixing bugs for the FastAI library as well. And that's one thing I also want to point out about contributing to the library. I think if you have any, when you're using the FastAI library, if there's something that you find is insufficient with the library, or there's maybe some problem you have, I think it's great if you can contribute back to the library and add that feature or fix that bug. And some of them can be simple bugs. Like for example, one time I found there was some problem with the extension. It didn't support one of the extension. I just made a quick fix it and submitted it. And that's definitely greatly appreciated by the entire community. Other times, I had found out there's this training technique that that wasn't supported in FastAI. I decided to add it to the library. And I would say that also contributing to the library is just a great experience for learning how to use developer tools and developer workflows like Git and GitHub. And these are the tools that all software engineers really use for practical applications. So I think if that's something you want to learn, this is a great way of doing that as well. And then just to briefly talk about how FastAI has helped me with my with my own research. So I'm a PhD candidate at UC Davis in biomedical engineering, and I've been using FastAI for my own research, applying deep learning to microscopy. I've presented at the ICML Computational Biology workshop, and hopefully we'll be submitting a paper also sometime this year focused on this research. I'd be glad to talk about that later on as well. And of course, yeah, a couple more slides. It's important to stay up to date with the field of machine learning, and these are some of the resources. Of course, as we talked about, Twitter is a great resource, and there are other resources like the machine learning subreddit, the FastAI Discord, and there's some other Discord servers and some other websites as well. And of course, important to keep in mind that the journey never ends. I think this is especially true for deep learning as a field that is rapidly moving. I've also taken the FastAI course a couple of times, and I've learned something each of the times that I've taken it, and of course from all the resources online. And I'm always reading new papers and always learning. So I think this is especially an important aspect of your deep learning journey. With that said, feel free to check me out on any of these social media or other channels, and that's the end of the presentation.
Thank you, Tanish. It's really, even for me, even though I know you for quite some time now, even for me, it's really exciting to see your journey, and still gives me the chills on how much it is people are able to achieve if you stick to a problem, and you've had your interest in biomedical, and you've stuck to biomedical, and it's really important to also realize that that's why it's important to find things that you really love and that really interest you, because otherwise it will be really hard for people to finish, and they'll give up when there's a roadblock. Here's a fun fact just for people in case I forgot to mention. Tanish is 18-year-old. So when he says he started back in it's 15, 16, we were probably 13, 14, or yeah, so that's just a fun factor for everybody. With that being said, this would be the end of the session today, but we are going to meet in Slack, and we are going to meet for the informal catch up where everybody can have their audio and video on, and we talk to each other, and we just get to know you guys as well and your expectations from the course. And Tanish, you're going to be around there for a little bit, so
yes,
you can ask your questions. Excellent. All right. See you guys in Slack. I'll post a link over there for Zoom, and we'll all meet you there. Thanks for today, and see you guys next week. Thanks, Tanish.
Okay, see you.